We're doing some questions here which concern the total surface area of a shape. Remember, the total surface area is the area of the outside of the shape. If you like, the number of square centimetres of graph paper that you could paste all over a shape to cover it. Or if you like, the shape of its net. If you were to make a cardboard shape on flat cardboard which could be folded up to make the shape, the area of the cardboard net would be the total surface area of the shape. For this one here, a rectangular prism or cuboid, to work out its total surface area, add together all the different faces. Now there is a formula for doing that, but I just like to think about it separately. What we've got is a rectangular front face here which measures 5 by 7. There's one around the back the same side as well, so the area of those faces is going to be two lots of 5 by 7. These side bits measure 7 by 3, and you've got two of them the same shape, so if I add on two lots of 7 by 3, and then we've got a top and a bottom. Now the top and the bottom measure 5 by 3, so there'll be two lots of 5 by 3. So we can just about do this one in our heads. 7 5s are 35, times 2 is 70, 7 3s are 21, times 2 is 42, and 5 3s are 15, times 2 is 30. Add all that together, 142, and the units are centimetres squared, because we're talking about an area. This is a sphere, a ball, and the formula for the surface area of a sphere is 4 pi r squared, which is interesting because what it's saying is the area of a sphere is 4 times the area of a circle of the same radius. So in this case it'll be 4 times pi, 3.142, times the radius, 3.2 squared, so times the radius times 3.2 again. Now I've done this beforehand on my calculator, and so I know it works out to be 128.70 metres squared. You might like to check. Next one is a cone, and I think you can see here at the top of the page we've got a formula for the total surface area of a cone. The cone's made up of two pieces. It's got a circular base, so area pi r squared, and this fan-shaped piece which will fold up to make the cone side itself. And that's got an area of pi r s, and s is the slant height of the cone, the cone's height measured on the angle from its rim right up to its apex. So let's find out, in this case, the total surface area equals pi rs for the side of the cone plus the base of the cone, pi r squared. So we've got a 3.142 times a radius of 5 times a slant height of 8. That will work out the side bit of the cone, and the base bit is 3.142 times r squared, so times 5 times 5, just squeezing it in there. Okay, you can do these calculations yourself. Don't try and do too much. Do this bit and this bit separately, then add them together. You get into some awful troubles trying to do too many steps on your calculator all at once. This works out to be 125.68 for that bit, and 78.55 for that bit, total 204.23. Okay, I'm just going to pause to set up. We've got some more questions on the next page. This question at the top of the page asks us to adapt a formula. See, the formula for the surface area of a cylinder looks like this. The total surface area, you've got the formula on the other page, equals 2 pi r h plus 2 lots of pi r squared. And the way that that comes about is if you were to unfold the cylinder and make a cardboard pattern to make a cylinder, this is what it would look like, a rectangle, which you could get that rectangle and you could roll it up to form a tube, and then two circular end pieces there somewhere on the side to form the two ends of the cylinder. Now this bit, the rectangular bit, has got an area of 2 pi r times h, and these are circles, so of course they're pi r squared, if you can read it. So that's how it comes about. Now you can, with that knowledge, you can adapt the formula. If you wanted just a tube, you don't want these circular end bits. So you don't want these two lots of pi r squared. The total surface area for a tube, so if we can draw it, so it's just without any ends in it at all, and it's got a total surface area of 2 pi r h, just this bit. A tin drum which is open at the top, well, we need one bit on the base but no top bit, so when it's all made up you can get in the top, but it's got a solid bottom, and so its total surface area is going to be, we'll have the 2 pi r h bit for the side but only one bottom bit. And a lidded drum, same drum, but this time we've got a bottom and we've also got a top, so its surface area is going to be 2 pi r h plus 2 lots of pi r squared, because we've got both the top and the bottom. Okay, and now we've got one more question here, and it's to do with a hot air balloon. The shape of the balloon is, it's sort of like got a hemispherical top and a conical bottom. I was to think that balloons were round, but if you look at them closely, that does seem to be the shape. This one's got a diameter of 30, the distance all the way across is 30, and an overall height of 35. So 35 metres is the distance from the top to the bottom. I need to find out its surface area because I'm asked to find out the construction costs. I'm given the cost per square metre of nylon cloth. I need to know the number of square metres that will be involved in making this. So what I'm going to do is I'm going to divide it into two parts. I'm going to call the hemisphere, the half sphere, area 1, and I'm going to call the conical bit area 2. So area 1 is half a sphere. So what I'm going to do is I'm going to get the formula for the surface area of a whole sphere, and then I'll times it by half. Now for a whole sphere it's 4 pi r squared. So if I multiply that by half, some of you will figure out that just means instead of having 4 pi r squared, we're going to have 2 pi r squared. That's fine to do it that way. If you're a little unsure of what you're doing there, just leave it as 4 pi r squared, work out the area of a whole sphere, and then times it by half. That'll be fine as well. So we want to go half times 4 times the radius squared. Now this, remember, we're given the diameter was 30, but that would mean that the radius from here to here is going to have to be half that. It'll be 15 metres in radius. So it's half times 4 pi r squared will be 15 times 15 again. Okay, now I've actually done this beforehand, and so I know that if you do all the computations there, it works out to be 1413.9 metres squared for an area. Now we come down onto area 2, which is this cone. Now remember, we haven't got a bottom bit in it anymore, so we have to adapt that formula for the area of the cone. Instead of area equals pi rs plus pi r squared, ours is going to be area equals, and we'll just have a pi rs for, pi s, not pi r squared, pi rs, where s is the slant height of the cone. Remember the slant height? The distance from here to here is called the slant height of the cone. And that's a problem, because we don't know it in this question. But I'm looking at this cone here carefully, and I do know the height of the cone from the base to the centre. I know that its vertical height, because we were told that it's 35 metres up there. The radius of this sphere is 15, so that means it's 15, or that means that bit is 15 as well, doesn't it? If it's 15 from there to there, then this bit from here to here must be 20 metres. Now I'm looking at this triangle here. It's a right-angled triangle, and I think you know how to find out the third side of a right-angled triangle. Can you remember? Maybe grade 8 or grade 9 we did Pythagoras theorem, and you used Pythagoras theorem to find the third side of a right-angled triangle. We could use it here. We can say that s squared, the hypotenuse side, is equal to the sum of the other two sides squared. S squared equals 15 squared plus 20 squared. That means that s squared equals 15 squared is 225, 20 squared is 400. That means s squared equals 625. That means to find s you take the square root of 625. Better just do it here to make sure. 625 square rooted equals 25. That worked out nice and easily. So the height of the cone measured on the slant from the apex to the edge is 25 metres. I can use that over in this formula here where I'm trying to work out its surface area. Pi is 3.142, the radius was 15, and the slant height was 25. Okay, I've done all this beforehand on my calculator now. I do know the answer, 1178.25 metres squared. So I've got my area for part 1 and area for part 2. The total area is equal to those two things added together, 2,592.15 metres squared. And we're nearly finished, but not quite, because the question said how much is the balloon going to cost. Each square metre costs $8.50. We've got 2,592 square metres, so the cost is going to equal 2,592.15 times the price per metre, $8.50 per square metre. Works out to be $22,000 and $33.27. Balloons are very expensive.